This is the Yaesu FT901DM that I fixed a while back in one of my videos. It had a problem with the power supplies. I had to recap the main power supplies, and I got it working. Display's still not working. I haven't hit that yet. But this has been sitting for a while, and now I noticed that there's no audio. So I have an external speaker hooked up. You can hear a slight buzzing, but nothing. There's no audio. And I did have audio at first when I powered this thing up, but so something else has gone wrong with it. So what I need to do, here is the audio board on the unit here. And that would be this board right here. This is the heatsink here. This is a scanned manual, and these aren't the easiest things to read. I printed out the service manual for it. But here's a suggestion for you. If you use the snipping tool in Windows and you just snip the outline of a drawing, in this case a schematic, or you can even do it with a circuit board, and then print it out. Here it is printed out a lot larger, so you can actually read the thing. You can see I can read it here, and do the same thing with the circuit boards. So here's the solder side, and I can pretty much read all the components here. And of course here's the component side. And what you also need to do is have an extender board, which here's the extender board I built some time back, so that I can pull this unit out, and I'll extend it so I can actually take some measurements. I'm going to start by measuring, make sure we got all our voltages here. The input comes in on sideband, comes in on pin 15. You can see right here, and it's fed through an audio chain. There is some filtering here. This is the main audio output IC that feeds the speaker. So what I'm going to do is check the voltages, make sure it's getting the proper voltages, and then I may run a signal in, see what the problem is there. Another problem with these older radios is relay contacts. Here's RL1, and on page 3-45 in the service manual, they've got a pinout here which shows the contacts. So you can test the relay. I put it in a vise here, and this one's open. Here's the normally closed contact. So the normally closed contact is working. Here's the normally open contact, and we have an open circuit. And I tested the other sections here. This is a 4-pole double throw relay, and this contact here, A, is bad. So I'm going to pull the relay apart and see if I can figure out why it's not making contact. I've got the ohmmeter in the conductivity mode connected across this suspect contact, and I'm going to energize the relay. You can see and you can tell, I don't know if you can tell, I'm going to take a toothpick, and I'm just going to push that contact a little bit closer to the other contact. And you can see if I keep it in frame here anyway, as you can see here, when I push that contact a little bit up it makes contact. So this contact needs to be bent up just a hair so it'll make contact. So I'll do that next. Well, the audio's back. It wasn't that regulator, it was a relay contact on right here. This relay that I just cleaned the contacts. One of the connections wasn't making a contact, and that was opening the circuit to the audio. So I got audio back. Alright, well, got my audio back, so I'm going to go back to working on why we're not getting any drive. That's next. Okay, the idling plate current is okay. Not getting any drive. The ALC is correct. So let's go back to plate current. When I hit the MOX, I'm not getting any drive to the output stages. So what I need to do is trace the signal from the signal source to the output. Now this diagram here in the service manual, the signal and control wiring, will help you to do that. And you can follow here. I marked in blue the signal path here. These are the circuit boards for the different sections. Starting at the carrier here, the output on pin 4 is connected over here to pin 3 on the IF board. If you follow it over here to pin 8 on the filter board, and the output on pin 17 is fed over to the noise blanker board, pin 8, and from there, pin 17, the output of the noise blanker board is fed up to the TXN J102 on the RF board. So what we can do is we can trace where we're losing our carrier signal here as it works its way through these different sections. The red shielded lead here is J103. This comes up from the noise blanker board and feeds the RF unit here. I can pull the RCA plug off here and see if I get my signal at this point. If not, I can work my way back to the carrier board. So I think I'll start here. It's an easy point to take a measurement from. And to do that, I just need to pull this connector out here, and I should get signal at this point here. This is the carrier board. The receiver's working, so I know that the oscillator's working, the signal's demodulated, it comes through this relay RL701, and then it's connected directly out to the balance modular out. That's on receive, so we know the oscillators are working fine. But here's where the problem seems to be, right here at T701. I'm going to measure at the primary of T701, and I should see carrier signal. And you can see here's the primary at T701. I got signal on the primary. And now these three terminals, this is a secondary here. This is a center tap. And I should get carrier here, I get nothing. And if you look here, so I have signal on the primary of T701, and then at the center tap here, it bypasses Q704 and outputted directly on pin 4. I'm getting nothing on the secondary of T701, so that's where I'm losing the signal. And once again here, I get signal on the primary and nothing on the secondary. So we need to check that out. Here is T701. It's the transformer on the top here. Something is pulling the signal down here. I think I'll replace this FET. That's probably the most likely candidate. I'll check some of the components around the FET, make sure it's getting... Well, you know what? I'm going to replace that FET. I think something is pulling it down. And if we had a shorted gate, that would cause the problem here. Anyway, that's my most likely candidate, I believe, at this time. This is the problem I found on the unit here. I wasn't getting any drive. The problem turned out to be Q704 on the carrier board. This is a dual gate MOSFET. This transistor was bad. I replaced it. And it seemed it was being fed too low of a signal. I did increase C715. I went up from 2 picofarad, I think about 5, 6 picofarad, I can't remember. But anyway, I had a little more drive into this transistor, and that solved the problem. Another point, when you're working on these, to measure the drive, if you look on the back of the unit here, there's an RCA jack down here, and you can measure a drive signal level there. That's an output that can feed an external device there, so you have access to your drive signal. And these are the original finals that were in there, and I had originally replaced those. I thought that was the problem, but they seem to be alright. I got another set of those I matched. They're pretty closely matched, but I'm going to leave these in there. This is a new driver vacuum tube here. The other one seemed kind of weak when I tested it. I'm still having trouble with the counter, so that's going to be another project I'll work on. Not sure where the problem is. This is the older counter unit. This is an early production run. I had replaced this cap. I'm trying to remember now. I worked on this one quite a while ago, and I never did get the counter working, so that'll be a future project. Here's the carrier board here. Here's the MOSFET. These 4 conductors here are the MOSFET. This is the transformer here. This is T701, and this is the cap I replaced. I increased the value a little bit from 2 picofarads. I got the scope on the output side of C715. Test 1 2, test 1 2. Hello, hello, hello. There's about 120 watts I'm getting out of it. I've got an old TS520 that I'm using to listen to the signal on. These trimmers were way off. I'm just in the 40 meter band right now, but this trimmer here and this trimmer here were way screwed out. So I don't know if someone had low output and they were trying to use the trimmers to tune it. I don't know. I'm measuring on the scope here. This is the This is the drive level here to the finals. I found a few discrepancies in the service manual I have for the FT901 here. In the description of the theory of operation, it shows on the IF unit it says the frequency of crystal oscillator 405 is varied by varactor diode D401. That should be D410. And if you look on here, here's Q405, the oscillator, and here is the varactor diode, which is D410 in the schematic here. So I found that to be a discrepancy. And I don't know, as long as these things were in production, maybe there was different manuals available. This is the only one I could find. In the description of the transmit section, on the RF unit, it says a single sideband signal from J102 of the PC board is fed to the balanced mixer consisting of Q106, but that actual jack is J103. And if you look on the schematic, here it is here, J103. J102 is a VCON. This feeds a amplifier here, a buffer that feeds the balanced mixer. This heterodynes the signal up to the output frequency here through this balanced mixer here. So the transmit, which is the red shielded cable, comes in on J103, not J102, as it says here in the manual. In the service manual, in the transmit section under the tune unit, it says when D2107 is grounded, D2102 turns on and the voltage appearing at the collector of 2102 is fed through D2109 to D701. I think they mean Q2102. If you look on here in tune, this relay activates, grounds the cathode of D07 or 2107, same thing. This is board 21, diode 07, and that turns on Q2102 or Q02 on here. So it appears that they meant Q2102 here in the book. Reading the service manual here, it says the DC voltage is applied through diode switch D912 and relay 701 to unbalance the ring modulator for CWAM and FSK operation. The resultant carrier is fed to T701. Well, if you look on the schematic here, here's relay 701. Here's the ring modulator here. When 12 volts is applied at pin 8 for CWAM and FSK, that 12 volts, if you follow it down, all the way down and all the way up, it's fed through D712, which would unbalance the ring modulator here, or the balance modulator here for CW. Well, I'm going to call an end to this video, and like I say, I may be updating if I can get this counter working here. Should be able to do it. This presented a lot of problems for me. I don't know. This, like I say, this was a Hamfest basket case, and it was really had some problems, although really nice condition, cosmetically anyway. Well, I guess that'll be it for this one. So for now, I'll say see 73s for now. Thanks for watching. See you in the next one.